Okay, so this is lesson 3.5. This is lesson 3.5, graphing piecewise functions. 3.5, graphing piecewise functions. And I'm going to abbreviate functions FXNS. I know that it is not how you spell functions, but I'm going to abbreviate that way. My suggestion to you with this, okay, is to, let's use the word split. Split apart the equations, and I'm abbreviating equations right here, EQ and S. Split apart the equations and graph separately. So that's step number 1. Split apart the equations and graph separately. Number 2, use the boundary line, and this will all make sense in a minute. Use the boundary line. Am I in your way? Sorry. And erase accordingly. Again, this will make sense in just a minute. So use the boundary line and erase accordingly. So the definition of piecewise function is that you have pieces of two functions, sometimes 3, but pieces of 2 functions that you only want a portion of that graph. Okay? So that's what we're going to do here. We're going to draw 2 graphs, but I only want a portion of each one. So if we look at this f of x thing, it looks like f of x, and they got lazy and just didn't write it twice, right? Because I have 2 equations, f of x equals x, and f of x equals negative 2x plus 1. Do you guys see that? Mm-hmm. They didn't get lazy. It's the way you write piecewise functions, but I like to explain it that way because it's really just 2 separate equations, okay? So we're going to break this apart. We're going to write f of x equals x. That was the first equation. And the second equation is f of x equals negative 2x plus 1. So I have 2 equations. And then I have this if x greater than or less than negative 3 thing. We're going to forget about that for a while because we haven't talked about that yet. So we're not going to worry about that till later. Okay? So I have 2 equations that I can graph. This red one, f of x equals x, that's really y equals x, right? What's the b value here? And y equals mx plus b. What is your b in this equation? 0, right? It's not there. So we know that it's 0, right? So our b value is 0. What is your m value?
1.
Remember where your slope is here, right? 1 over 1?
No.
1 over 1. Yep. Okay, so go over to your graph. We always start on our b, so we're starting at 0. And then I'm going up 1 and over 1. That's what my slope said. Up 1 and over 1. Up 1 and over 1. Up 1 and over 1.
Is this where we needed our marker?
Nope, not yet. You don't need your marker yet. So we're going to go ahead and draw a line going all the way through. Are we okay with that line so far? I have some rulers for you if you'd like some. Okay, so then we're going to do the same with the purple one. What is the b value here on the purple one? 1. What is your slope here?
Negative 2 over 1.
Negative 2 over 1. Go ahead and graph that. On the same graph. Would anyone like a ruler? Okay, so we're going to go where on our B value here? Up 1. And then where do I go from there? Excellent. Okay, so we're going to go up 1, right? And then down 2 and over 1. That's what our slope tells us to do. Down 2 and over 1. Down 2 and over 1. And you want to make sure that your graph is going the length of the grid. That means don't just make it in the middle. Make it go the whole thing. Oh, down 2 and over 1. All right, anybody have questions so far? We're okay? No, we're not going to do shading. We're going to do some erasing. So now we look at the boundary line. And the boundary line is at -3. So we know that because we can look over here and see our boundary line is at -3. So this is where you take your highlighter or other color pen. And when x is -3, you're going to draw a dotted line all the way down. Can you guys see? Oh, you can't really see that green, can you? Let's use a color you can see. Can you see that blue? Kind of.
Yeah. So it's better. There we go.
Okay, this is our boundary line.
And it's got to be dotted, you said?
Mm-hmm.
Don't forget the arrows.
Yep, it goes all the way through the graph.
I definitely forgot mine.
All right. Everybody with me so far? Okay, all right. Quiet crowd today. Thanks, girl. All right, so let's look at this condition. It says f of x equals x, so I'm looking at the top condition, okay? This one right here goes with the red graph. So for this one, I want everything where x is less than or equal to -3. So if I'm looking at my red graph, and I want to see where is the graph, the red graph, less than or equal to -3. Would you guys agree that this direction is less than -3, right? It's going to the left of that line, right? It's going to the left over here, which is less than -3. Would you guys agree with that?
Yeah.
So that's the part of the graph that I want to keep, okay? Because it satisfies that equation. It's less than -3. So going down that arrow that I made really big bold, that's what I want to keep. So I'm going to erase everything over here. Okay? So I erased the other part of that graph because that part was greater than -3. And I want what is less. Nope, we're not dealing with the purple yet. So that was an accident. Then it accidentally went through there. Okay, now do I want to include -3? So now I have to look to see, is there an equal sign with my less than symbol?
Yeah.
There is, right? And equals means I have a closed circle. Do you guys remember that? Oh my gosh. So I'm going to draw a closed circle right here on the dotted line at -3. So you're going to draw a closed circle there. Okay?
Doesn't matter where it's at.
Where the red line hits the blue line, where the graph hits this imaginary, yes, that's where you want to draw your circle. Mine's a little over-exaggerated so you guys can see it. But yes. All right, so now let's look at the purple line. The boundary that goes with the purple line says what?
X is greater than -3.
X is greater than -3, right? So I want everything on this line where x is greater than -3. So greater than -3 is this direction, right? Would you guys agree with that?
To the right.
That's to the right is negative or greater than -3. So every part of the graph that is greater than -3 is the part that I want to keep. So that's going to be this whole thing. Make it a little bit bigger. This whole thing I want to keep. So I'm going to erase what's over here.
I'm gonna put an open circle.
On the left side of that blue line. So if you didn't extend your graph all the way, then it maybe didn't go all the way over there. Okay, but whatever was over here, that's what I erased.
This is
Okay?
so weird.
It is weird. Okay, now do we want an open circle or a closed circle? An open circle on the blue line.
We already have an open circle online, don't we?
No, we had a closed one with a red graph. Now I have an open one with a purple graph. Okay? Do you see how your graphs are going opposite sides of your blue imaginary line? Or whatever color yours is, right? They're going opposite directions. They should. Okay? You shouldn't have them both on the same side of the boundary line. Okay? All right, let's do another one so we get the hang of this.
I'm gonna buy you a heater.
Oh, what? All right, number 2. The first thing we need to do, we're not going to worry about domain and range, so you can use that space there if you want to.
Oh, I thought we were going to use it, so I tried to write all around it.
Okay, so we have 2 equations, right? So this first one says g of x equals negative 3x minus 7. You guys see that? Okay, and we're going to worry about the condition later. The next one says g of x equals negative 5. So we're going to graph them one at a time. So if I have negative 3x minus 7, what's my b value?
Negative 7.
Negative 7, and my m, my slope? Negative 3 over 1, right? Okay, so let's go down negative 7. 7. But the problem is, I can't go down 3 into the right one.
You go up to
Good. Up 3 into the left one. Good job. Okay? Go ahead and do that. Up 3 into the left one.
So 7.
Oh man, that's not a good line.
I got a ruler and this still ain't a good line.
The more dots you draw, or points that you draw, the more accurate your graph is going to be. Okay, we got that one graphed. The next one says g of x equals negative 5. So in this one, this is just like saying y equals negative 5. What kind of a line is that if it's just a y?
What is it?
I see something. Good. A horizontal line. Good. At where?
Negative
At negative 5. So I'm going to go 1, 2, 3, 4, 5. And I'm going to draw a horizontal line at negative 5. Okay. Can you guys see my purple line? Okay. So now we're going to look, where is our boundary line? Where's our boundary line at? Negative 1. So we're going to draw a dotted line at negative 1. So at negative 1, I'm drawing my boundary line.
I keep wanting to put my hands
Is your boundary line always going to run up and down?
Yes, your boundary line will always be vertical because it's always going to be x equals something. Okay? All right, so now let's look at the red line, my red line. It says I want everything that is less than negative 1. So which direction is less than negative 1? To the left or to the right? To the left, right? So I want to keep everything that is to the left of that line, which means I'm erasing down here. Agreed? I'm erasing down here. Everyone see that?
Yeah. Oh, light bulb.
I don't know.
I get it.
I just had like.
Okay, so it was here, right?
But I know it's less than, so how do you know which one you want to keep?
So you want to keep the one that satisfies. So it says everything that's less than. So I want to keep what's less than. Yep. So I'm going to erase this all the way to that blue line. Now, for the red line, do I want an open circle or a closed circle?
Open circle. And then
Open, right? Because there is no equal sign. So I'm going to draw an open circle right there on the blue line. Can you guys see my open circle? Don't fill it in. And then, I don't want to go too fast, so if I'm going too fast, pause me. But on the purple one,
I know.
okay, on the purple one it says everything that is greater than or equal to. So which way is greater than -1? Not up, to the right or to the left?
To the right.
To the right,
And
right?
it's going to be closed circle.
So then I want everything that's over here, to the right. So that means I'm going to erase
These aren't that bad.
this guy. Any questions on that?
Yeah, that's weird.
It is weird. You're right. It's very weird, and it's different than what you've ever done before. But do you have questions on which side to erase? Are you okay so far?
So, what?
Hang on. Shh. How do you know what?
I don't understand what to erase.
Okay. So let's look at this one. You're okay with my line here? Okay.
Yeah, that's fine.
And then do you see I want everything that goes with the -5 that's greater than or equal to the -1. You see that?
Where did you get the okay.
You see it? It says if x is greater than -1. Okay? So that tells you which side you want to keep. So it says I want to keep everything where x is greater than -1 on this graph. Which means you're going to erase, Taylor, that left side. Did you guys say open or closed circle here?
Closed.
Good, closed circle, because there was an equal sign. Again, do you see how these two graphs are going on opposite sides of that blue line? Okay, they should be going on opposite sides. They should not both be on the same side.
Now you want to put your circle on the line?
Yep, your circle on the line because it's going to go right up to that line to touch. Sometimes your dots will be really close together. Yeah, and they should always be on the blue line. Yes.
Will you ever have a parallel one of these things?
Parallel lines or a parabola?
Either.
The line will always go up and down. It won't go side to side.
Just like, but I'm saying like if you were like how we had like the red and
On number 3, I changed the graph a little bit. Okay, so the first one says y or g of x equals -5/2x minus 1. And then the second one says g of x equals x squared. So let's graph the red one first. We know how to graph that. The b value here is -1. Your slope is -5/2. Doesn't matter where you put the negative, either top or bottom, but not both. Okay, go ahead and graph your red line.
Does that say x squared?
Mm-hmm. We'll get to that in a minute. So I have -1, and then I'm going down 5 and over 2. You can go up 5 and back 2, yep. Make sure you draw your line all the way through the graph. Okay. Now, what does an x squared graph look like? It's a parabola, right? Isn't this one of these guys? Right? That's what it looks like. Now, there's nothing touching, like there's no -b/2a, right? Because there's no bx term. There is no h and k out here, right, for us to find. So when it's just x squared, that means it's starting at the very, beginning, which is at 0.
Going up 2.
Nope, not going anywhere, just opening up at 0.
gonna leave it like I have.
Okay. So we're just going to graph it there. Everyone okay with that parabola? Make it a little bit wider, okay? Don't make it super skinny, make it a little bit wide. And where is our boundary line here? At, what'd you say, Aspen? Positive 2. So at positive 2,
I'm gonna try to figure this out by myself.
okay, yeah, go ahead and try to figure it out by yourself. See what you guys can do. So, do you see this right here? Those two numbers will always be the same for both of them, and that's how you know where to put it. So if you look at the previous ones, I think it was like -1, -2. You see where it is? Yeah, okay, cool.
So would you erase half the little practice?
Interesting. Okay, let's talk about our red line. Okay, on my red line, I want everything where it says x is less than 2. So x is less than 2. Taylor, which side are you going to erase on the red line? If you want everything that's x is less than 2, which side are you going to erase? The right side or the left side?
The right side?
Good, because that's greater than 2, right? So we're going to erase the right side. Perfect.
Oh, sorry.
Are we going to have an open circle or a closed circle, Vinny? Is there an equal sign with this too?
No.
Okay.
Now, where are we supposed to put our little...
Right here, wherever the red line is getting ready to touch the blue line, the dotted line, that's where you put your circle, right up against it. Okay. All right, so now my purple parabola says I want everything where x is greater than 2. So greater than 2 is going to be which side, Samantha? Which way is greater than 2? To the right?
Yeah.
Or to the left?
right.
To the right. So you need to erase everything over here, including all the way up to the line. So like this shouldn't be here.
That's
It
right
needs to
in
be
that,
on the
though.
blue. What'd you say?
That's right in that.
Nope. It still has the left. This is the left side of that blue line, right? This is the left side of the blue line. So if your parabola didn't stretch far enough, did your parabola go past that dotted line?
Yeah.
Okay, so then you should still have this part of your graph left. Because that's the right side, that's greater than 2, right? Everything over here is greater than 2. And I'm going to fix this. Is there going to be an open circle or a closed circle on the purple? Open. So there's no closed circle this time.
High five.
Okay? Did anyone get that one right?
I messed up, but I...
A little bit. We're getting closer. Okay.
I did the opposite. You get what I'm saying?
See,
Like, one of them I...
Well, I started
remember,
erasing this.
you know when you did like...
All right, last one.
You do like the shading part. I try to remember that if I had my...
Number
hand,
4.
Whatever it was.
What do we notice that's different about number 4?
There's 3.
There's 3.
And,
Oh no.
And the little...
Okay, so that just means we're going to have 3 situations, okay? So we're not going to panic. We're going to take it one at a time. So the first one says g of x equals -1. So let's put that graph on there. What kind of a line is that? A horizontal line at where?
-1.
-1. Okay, put arrows on the end so you can see. Sometimes it's hard for your pencil to see on here, so if you're not putting it in bold, make sure that you put arrows on the ends of it. Okay, the next one says g of x equals -x minus 3. So I have a b value here of -3 and an m value of -1/1. We okay with that, Vinny? Okay. So where are we going to start this one? Aspen? Where do we start it? At -3, good. Then we're going down 1 and over 1, right?
Yes.
Remember, the more points you draw, the better your line is going to look. Use a ruler. And then I have another line that is at g of x equals 6. So what kind of a line is that going to be?
Vertical.
Not a vertical. Another horizontal line at where? At 6.
So how do you know if the lines are vertical or horizontal?
So whenever it's g of x, that's another way of saying y, right? Y equals 6. You remember that? G of x is the same thing as saying y. And anything that's y equals 6 is a horizontal line. Yep.
I don't remember which one was my first one.
Okay. So we have everyone okay to this point? Raise your hand if you're to this point. You're okay with these 3 lines on there? All right. So now we have 2 conditions this time. I have 2 boundary lines, right? I have one of them is at -5. Where's the other one, Olivia? +1. So at -5, I'm going to draw a dotted line. And at +1, I'm going to draw a dotted line. It's helpful to use different colors, as you can see. Okay, so draw your 2 boundary lines. And we're going to go a graph at a time. So the first one was my red graph. Okay? And that one said I want everything that's less than or equal to -5. So less than or equal to -5, if I'm looking at the -5 graph, less than -5 is to the left, correct? Mm-hmm. Okay, so my red line, I want to keep everything that is less than or equal to -5. So I want to keep what's on the left. So I'm going to erase what's on the right. Now, do I want an open circle or a closed circle on -5?
Close circle.
Good, closed circle because it's equal to. Excellent. Okay, now the middle one is actually pretty easy, guys. Let's look what that says. I want everything on the purple line that is between, right? Everything that's between these two. So I don't even have to choose which side, right? I just want whatever is between, which is just this right here. So that means,
Between.
because if you read this, it says less than -1, right? And then greater than -5. X is less than -1, but greater than -5. Yep. So the purple line is just what's in the middle there. Okay. Do I want open circles or closed circles for this middle line? Both of them are open circles. Good.
You put two of them, right?
You put one on each, right? So one over here.
What kind of analysis is this?
And one over here. You guys are doing great. We're almost done. Not me. Okay, and then let's look at this last one.
I'm not negative, positive.
Okay, so it says on the green graph, I want everything that is greater than or equal to 1. So greater than or equal to 1 is which way? To the right. So which way am I going to erase? To the left. And we'll have an open circle or a closed circle? Good. Closed, yep. Now, do you see how none of the graphs are overlapping? Do you see how they're all different? None of them are overlapping each other? That should always happen. They should never overlap each other.
Does that mean our function?
Yeah. Yes.
Oh,
Good job.
look at you, Annie.
Okay, any questions on this? On your homework, okay? Look at page 17. Listen carefully. On page 17 and 18, you need to do 7 through 11. That's it. 7 through 11. You do not need to find the domain and range. You just need to graph them. 7 through 11 on homework 18. Pages 17 and 18.